Hello my future subscribers, welcome to my first video. As you may know from the description, my videos are going to be about the IB Diploma Mathematics AGL subject. I will try to cover all the topics of the syllabus of Mathematics AGL. And to start with, I have decided to cover counting principles, especially arranging objects part in this first video. So we are not going to look at permutations and combinations yet. We will just look at how to arrange objects using factorial. And then in my second video I will introduce you to permutations and combinations. This is just a basic foundations for counting principles. So first of all, what is a factorial? Factorial is the product of the integer and all of the positive integers below it. So for example, if we say factorial of, what is factorial? So for example, if we say factorial of 7, we denote factorial with this mark. So remember this, whenever you see this, you understand it's factorial. So it's equals to 7 times 6 times 5 times 4 times 3 times 2 times 1. And then this equals to some big number. It's a big number. It's not too big, but it's a big number. And for example, it works for every positive integer. If you say 3 factorial, it's 3 times 2 times 1. And this is a very important thing. You should remember that factorial of 0 factorial, is 1. Of course, you think, how come it's like 0 times 0? How come it can be 1? But it's 1. I don't know. So, let me mark you. You should always remember this, because whenever you have, whenever we reach the part of Gaussian distribution, sometimes you will see 0 factorial at the bottom of the 0 factorial here, and then you will say, how come this can happen? But it equals to 1, so you can divide actually. We are going to use this factorial to arrange objects. For example, have you ever thought how you can, if you had like 10 US presidents with you, how you could arrange them? For instance, like you have Abraham Lincoln, you have Washington, you have Hillary, you could have Hillary Clinton, you have Donald Trump, you have George Bush, you have Barack Obama, you have Reagan, and like all of them, and you want to arrange them in a line. How you could do it? You could arrange Clinton first, then Washington, then Obama, or you could place Obama first, then Washington, then Clinton, and there are hundreds of thousands of possible ways you could arrange them, because if one changes its place but the others are unchanged, it is also a way. So let's do an example and make it clearer for you. Let's start. Okay, so first example, in letters of the word object, how many ways can the letters of object be arranged? So we have the word object. So 1, 2, 3, 4, 5, 6. We have 6 letters in it. So first of all, how many ways can be these letters arranged? So let's think. There are 6 places, right, to arrange them. 6 places. Okay. So think. how many of them can you place here? Of course you can place 6, right? You have 6 choices to place here. You have 6 choices. You can place O, you can place B, you can place J, you can place E, you can place C, you can place T. But here it's one less. Here it's one more less, because you already arranged 2 of the letters here, so it's only 4 left to arrange. Here it's 3, 2, 1. And we should always remember, I didn't cover it, but as I'm explaining you, I think it's beneficial to explain you. If the objects are AND, like it means we should have O and B and J, we should have the letters together, then we need to multiply them. So we should say this is equal to 6 times 5 times 4 times 3 times 2 times 1. And what this equals to? Of course we know it's a factorial of 6. And factorial of 6 equals to 6, 24, 120 and 720. So it equals to 720. So there are, actually you think, oh, object, it's such a small word, how come you can arrange them in 720 ways? But if you do it, and if you start doing it on a piece of A4 paper, you will really notice that there are 720 words. So B. In how many ways can this be done if the B is to be the first letter? So 1, 2, again our 6 boxes. So B is here. If we want B to be the first letter, it could be here. How many ways can B be here? Only one case. There's one case. So 1 times. How many ways we can arrange the rest? If we delete the object, if we have object, right? And then we delete this B, there are 5 left. So we should, how many can we arrange here? 5, right? O, J, E, C, T. We can 5 times 4 times 3 times 2 times 1. So we have got 5 factorial times 1. So what's it? It is 120. So yes, if we want B to be the first letter, there are only 120 ways of arranging them. See, it shortens. Whenever there are this type of questions and you attempt the second one, you try to compare the first and second result and see if the second result of this type of a question is bigger than the first one, then you are certainly wrong. And the question C. In how many ways can this be done if E and C are to be kept apart? So what it means that in the 6 boxes you can't have E and C next to each other. So let's draw the 6 boxes. So how we can attempt to this type of question? In this type of questions, it is better to use the alternative method, because counting straight how many ways are there of arranging and E and C separately takes very long time and it's quite tedious. So in order to count that, let's take how many times are there when E and C are together. If we then minus this times from all of the times, from 720, we will get the ways of arranging E and C apart, right? So we count how many, first of all, we count how many ways are there of arranging E and C together. So how many ways? Okay, first of all, think, how many ways are there of arranging E and C? 2, right? you can arrange E first or C next, or C first and E next. So it's 2 permutation of 2. Then you should times how many ways are there of arranging the rest 4 letters. It's if we have like occupied, this one occupied right here, then we have 4 times 3 times 2 times 1, right? Then we have permutation of 4. And then it's very important, you should not forget about this, we should times by how many times this E and C can be arranged here. So first of all, let me mark E and C with star. Is this star, right? So E and C can occupy these 2. They can occupy these 2, right? These 2, then these 2, or these 2, or these 2, and these 2. So we got times 5. So as a result, we have got 2 times 4 factorial times 5, which gives us 240. So there are 240 times where you can arrange E and C together when arranging the word. But our question was different. We should have found how many ways are there to arrange the word without E and C together. So we just take this 700 and then we do minus 240 and then we get 480. There are 480 ways of arranging E and C apart. So today this is the end of the lesson. Next lesson I will cover permutations, combinations, and then we will attempt some harder problems. And there are some things I explained you can be explained using combinations, such as this one, or permutations. But I have tried to explain you in a simpler way to just bring you a foundation of counting principles and arranging objects. Thank you very much. Don't forget to subscribe. See you next lesson.
Ամեն օր եմ ես սպասում քեզ, հասա ուր է սիրելիս, հավքերը եկան, տուն դարձան, դու չկաս, էլի սիրտս է լալիս, ամեն օր եմ ես սպասում քեզ, հասա ուր է սիրելիս, հավքերը եկան, տուն դարձան, դու չկաս, էլի սիրտս է լալիս, ինձ այրող սիրո կրա